Think in terms of the complex conjugate. Don't divide. We're going to use z as a complex number. We can express it in two ways. In rectangular form, it's going to be a real part x and an imaginary part y. In polar form, z is going to have a radius and an angle theta. We're going to use lowercase j as the square root of a -1. Alright, I'm assuming that you know how to create formulas for a circle. We can see a complex formula for a circle that has an offset. It's not centered at 0, 0. And here you can see the code. NumPy's here. And then basically starting here and going down is all matplotlib. Here you can see that we're making a list of numbers, about 700 numbers. Each of those 700 numbers is a dot here in the circle. So this is the t-axis, which is this red axis here. And circle plot is the y-axis right here. This is all rectangular thinking. But you can see here I did not create the y-axis by using this equation. I did it using polar circular thinking. So the plot here doesn't really help us a lot. It has a point going through the origin, but its center is right around, well, it's at that 3 and a -4. It's right about right here. This doesn't help us build our intuition. And we're creating all these dots up here to create the circle, so it's really painful. If you look at this code, you can see just a circle command, a circle command, a circle, draw a circle. 1, 2, 3, 4, 5 circles. So you've got 1, 2, 3, 4, and then this blue circle's 5. This comes from the coordinate system. This is like the x and y coordinates, except for we have radial coordinates and angle coordinates. So we need to learn to plot a different way, and it actually is much simpler. This is a much more complex diagram than this one. This one helps build our intuition. Now we're told to plot this equation. And coming from the rectangular world, it just makes your head spin. You have no idea where to start. You have to switch to circular polar thinking in order to solve it. You have to find the circles in it to solve it. So here I'm doing some of that math and plotting it. Now there's no real way to plot it with circles because we end up with a straight line. And this is what it looks like. So even though there's a straight line right here, and these are the 2 points, and this is the line that's equal distance from both of these points at all places. So here it's exactly halfway between the two of them. But here that distance and this distance are the same. So even though we had to go to circular thinking to actually do the math, we had to use rectangular to plot it because there's a straight line. The goal here is just to get you to think circularly to solve the equation. Okay, so let's make the power of z 0. So we can go to, there's 1. Okay, there's 1. Now when we raise z to a power, all we're doing is we're taking this angle and we're multiplying it. So if we go to 2, we multiply it, but you can see it's not right on the line. That's because we started with integers in the real world and moved to the circular polar world, transcending through e and pi, so we end up with a irrational number for our angle. And we can't ever get it exactly on 0 if we go all the way around. Right? Between 16 and 17, you can see there's this accumulated error because of the transcendence. Same thing going to negative powers. Now you can see that it's rescaling the radius at all times. So this is a 0.006 radius. If I go to a 0, that's a 1 radius. And now you can see the scale here is now 5. We're not really paying attention to the magnitude of that point. We're paying attention to the angle. Angles are much more interesting in this course. So if we're not really paying attention to the magnitude of our number, if we're only paying attention to the angle, then what happens is dividing becomes the conjugate. So here we're plotting the complex number z. So there it is. There's a dot representing z, 3 minus 4j. We're computing the conjugate of it. And the conjugate of it is just changing the sign of the angle. Now, obviously, the magnitude should change, and we're not changing. If we were going to change the magnitude, then it would look something like this. But the angle is going to remain the same.